two events A and B are such that probability of A equals to 1 on 3, probability of B equals to 2 on 9, and the probability of A given B is equals to 1 on 2. Find A, probability of A intersection B. B, probability of A union B. C, probability of B given A prime. A, find the probability of A intersection B. You know, from the definition of conditional probability, the probability of A intersection B is equals to the probability of A given B times the probability of B. The probability of A given B is 1 on 2 and the probability of B is 2 on 9. Substituting this information in this formula, I will write half in the place of probability of A given B times probability of B, which is 2 on 9, and then I will have 1 times 2 all over 2 times 9. Multiplying two fractions, we multiply the numerators and then we multiply the denominators. That is, I will have 2, which is 1 times 2 all over 18, which is 2 times 9. Simplifying this, I'll have 2 here 1 time, 2 here 9 times, and then I'll have 1 all over 9. That means probability of A intersection B is 1 over 9. The next is to calculate probability of A union B. You know, by definition, the formula to calculate the probability of A union B is given by probability of A plus probability of B minus probability of A intersection B. I know from the question probability of A is 1 over 3, probability of B is 2 over 9, and probability of A intersection B is 1 over 9 as I calculated from the A part of the question. So I will substitute the information in this formula to obtain probability of A union B. That is, in the place of probability of A, I will write 1 on 3 plus 2 on 9 minus 1 over 9. Now, these are 3 fractions, so to simplify, I need to look for the LCM. The LCM of 3 and 9 is 9. 3 can go to 9 3 times. 3 times 1 is 3. 9 divide 9 1 time. 1 times 2 is 2. 9 divide 9 1 time. 1 times 1 is 1. So I'll have 3 plus 2 is 5. 5 minus 1 is 4. That is 4 over 9. That means the probability of A union B is 4 over 9. So I have 4 over 9 here. C, find probability of B given A prime. You know, from conditional probability, by definition, if we have two events, let's say A and B, the probability of A given that B has occurred is written like this and is obtained by the formula the probability of A intersection B all over the probability of B. If you compare this notation and this one, you will discover that the events here are B in the place of A and A prime in the place of B. So the formula to calculate the probability of B given A prime will be probability of B intersection A prime all over probability of A prime. You see, probability of B intersection A prime was not given and probability of A prime was not given. So I need to calculate probability of A prime and probability of B intersection A prime. You know, in probability, if we are given an event A and let's say another event A prime, which is A complement, to calculate the probability of A complement or A prime, we take 1 minus the probability of the event A. That is the formula to calculate the probability of the complement of an event. You see, in this case, probability of A was given as 1 over 3. So it means here I'll write 1 minus 1 over 3. That is 1 times 3 minus 1 all over 3. That is, this is a way to simplify a fraction and a whole number. That is 1 times 3 is 3. 3 minus 1 is 2. So it means the probability of A prime is 2 on 3. Now I need to substitute here. That is probability of B intersection A prime all over probability of A prime, which is 2 over 3. So I need to calculate probability of B intersection A prime. you know that from complementary events, the formula to calculate the probability of an event, let's say B, is given by probability of B intersection A plus probability of B intersection A prime. But my problem here is to calculate probability of B intersection A prime. So I need to make it the subject of this formula. That is, I'll subtract probability of B intersection A from both sides of this equation. That is, probability of B minus probability of B intersection A is equals to probability of B intersection A minus probability of B intersection A plus probability of B intersection A prime. So anything I do to the left hand side of the equation, I also do to the right hand side of the equation. And you see this one, it means that probability of B minus probability of B intersection A is equals to 0 plus probability of B intersection A prime. That is, 0 plus probability of B intersection A prime is the same like probability of B intersection A prime, and here is probability of B minus probability of B intersection A. So you see that probability of B intersection A prime is equals to probability of B minus probability of B intersection A, and you know that probability of B intersection A was not given in the equation. Instead, we have calculated probability of A intersection B from the A part of the equation. So I need to calculate the probability of B intersection A. You know, from the intersection of sets, A intersection B is equals to B intersection A. That means the probability of A intersection B is equals to the probability of B intersection A, which is equals to 1/9 from the A part of the equation. Now, probability of B intersection A is 1/9, so I need to substitute here. That means probability of B intersection A prime is equals to 2/9 minus 1/9. That is, probability of B is 2/9 from the equation. That means probability of B intersection A prime is equals to 1/9. That is simplifying these two fractions, so they have the same denominator. When two fractions have the same denominator, I just simplify their numerators, taking care of the sign between them. That is 2 minus 1, which is 1, and then I recopy the common denominator. So probability of B intersection A prime is 1/9. I need to substitute here. That means here I'll write 1/9. Now these are two fractions that are dividing. So to simplify this, I'll invert the fraction at the denominator and I will multiply by the one at the numerator, like this. 1/9 times 3/2. So I invert this one. 3 goes up, 2 comes down. Now I multiply. To multiply two fractions, I multiply the numerators and then I multiply the denominators. That is, 1 times 3 is 3 all over 9 times 2 is 18. Now I can still simplify this fraction. 3 here 1 time, 3 into 18 is 6 times. So it means that I'll have 1/6. So it means the probability of B given A prime is 1/6. So the correct answer here is 1/6.